It's time for Pure Performance.
Get your stopwatches ready. It's time for Pure Performance with Andy Grabner and Brian Wilson. Hello and welcome to another episode of Pure Performance. My name is Brian Wilson, and as always, since this one is being recorded on October 28th, my annual guest, this co-host this year, is Andy Candy Grabner. Andy, welcome back. It's good to have you again.
I guess this is a reference to Halloween.
Yeah, way back. You don't remember this, do you?
I know you're so this now.
Way back. It was like your Halloween name was Candy Grabner, like as in candy grabber. Like you're the guy who walks down the street grabbing candy from the kids who are trick-or-treating. Yeah. Because you're the grumpy old man.
When I grew up as a kid, at least here in Austria, Halloween was not a thing. Now it's getting more and more popular. And but I think I never did. I saw it when I lived in the States, obviously. Yeah. I was watching the kids walking by and knocking on our door. And then I didn't know what they want from me. And I said, go away.
It's always a good excuse to buy a bunch of bags of candy that you like in hopes that no one comes. And then you're stuck with all the leftover candy. But that's why it's always important to buy the candy that you like. But anyway.
Exactly. Yeah. I think this is not an episode about candy or Halloween. But it might be a little spooky for some because we're talking about things that happen in the cloud. Ooh. And not every one of us knows what's really happening in the cloud. But we have somebody here as a guest that knows exactly what's happening in the cloud, especially when we talk about Azure and when we talk about Spring and we talk about Spring Boot applications in the Azure cloud. And without further ado, Asir, I hope I get your name correct, but please do me the favor, introduce yourself to our listeners.
You got my name correctly. I'm Asir. Thank you for inviting me. At Microsoft, I'm on point for everything developers and customers need to build, migrate, and scale Java apps on Azure. I'm also a Java developer. I started in 1995 with JDK1, and I've been having an amazing time with Java ever since.
And you've stayed there for 26. Is it 20? Do the math correctly? 26 years on Java.
26 years on Java. And 17 years at Microsoft. Wow. Just focused on Java all the time, right? And with Azure, it's really like a big playground where you can do amazing experiments with Java, amazing innovations with Java. So that's what I really, really like about Azure.
Mm-hmm. Now, I think Brian and I, right, we also have Java backgrounds, at least when I started my career as a performance engineer. There was a lot of Java apps that we tested when I was still working for a testing load testing company, and then as I switched over to Dynatrace, it was the initial idea and the capabilities of Dynatrace was tracing Java applications under load, and this was also by the internal name. It was the first name of Dynatrace was actually JLoad Trace, so for Java load tracing.
Oh, really?
And
I didn't know that, Andy.
See, trivia.
There you go.
Perfect.
I mean, I knew lowercase d, capital T. Yeah. But not J.
If you look at the very old Jira tickets, the project was called JLT for Java Load Trace, because the initial idea was, Bernd, our founder, and some others. We were back then at Segway and Borland, and which is now Micro Focus or HP. I don't even know what they are right now, but we did performance testing mainly against Java apps. And so Bernd then said, hey, why can't we do automated distributed tracing on Java apps under load to really find out where things break? So Java has been also with me for a long, long time. And also Microsoft. I remember I started my career in 1998. Mm-hmm. And it was a shop where we mainly built applications running on Windows. So Microsoft was always big for me. I did all of my Microsoft certifications. I don't remember what this was back then. Windows NT and all this stuff. Long time ago. 95, yeah.
Yeah, we had when I was at WeightWatchers.com, we were an early .NET shop. So we used to get invited to do our load testing down at the Microsoft lab in South Carolina or North Carolina. I always forget. And that's where I actually met Mark Tomlinson, whoever, friends of the show know. But it's funny because you mentioned that you've been doing Java with Microsoft for 17 years. And that's, again, so the repeated theme we've seen with Azure, right, is Azure is not the old Microsoft. And obviously, it's even crazier that you've been doing Java at Microsoft for 17 years. So that means that was the .NET heavy Windows-based one. But obviously, Java being platform independent, they're no fools. They're embracing that. So it just goes to show, you can never doubt what Microsoft is doing, or you can never think you know what Microsoft is doing, because they're doing a million things that always surprise you every day, right?
It's also about the success of the Java developers, right? Java developers have been amazingly successful, and you can see new students, new professionals, they're all learning Java. So it is that success that translates into Azure being an amazing environment, and today it's almost like a home. It is the home of many, many, many enterprise Java apps today.
Now, can you tell us a little bit, right? If I'm a developer, and I assume we have a lot of developers listening in, and also performance engineers, SREs, whatever they call them. Can you explain a little bit why somebody should deploy their app, their Spring Boot app on Azure? What do you offer that makes it easier for them?
Yeah, so Spring Boot developers, right? When they deploy, they also need a cloud platform where they can deploy scale with minimal effort, but maximum impact, right? So this is where when they deploy Spring Boot apps, they need several things around it for dynamic scaling. Monitoring, right? Monitoring is such an important piece. They also want the app life cycle, so their community of developers within their teams can work together and build, right? This is where they could always start with any virtual machines or containers. If they do that, they have to build this dynamically scalable infrastructure and monitoring all these pieces. Now, that will take a significant amount of time. Now, many of our customers, developers, we see them trying to build that on containers and virtual machines, and they build it as they go. When they do that, there are some challenges. The challenges like these learnings and trying and doing it can translate to downtimes, loss of revenue, not meeting the end user requirements or even the business requirements, right? So this is where when they deploy to Azure, we built a new service. We announced it like 2 years ago. It's now generally available. Many customers are deploying and running them in mission-critical systems on production. Now, when they deploy to the service called Azure Spring Cloud, all they have to do is just deploy the jars, and they're done. And then they can just scale. They can scale unlimited, right? Within a matter of minutes, they could be serving billions of requests per day, or even millions of requests per day, right? Now, when it comes to monitoring, it just becomes magical. Everything is wired up. All you have to do is activate whatever tools you like, including Dynatrace, particularly Dynatrace. And magically, you're going to see some meaningful insights, actionable logs and metrics that they can really act on it, right? So this is where they can deploy to Azure and not worry about all the running the scalable systems, wiring them all up, and building app lifecycle. They don't have to worry. I mean, I just mentioned 3 things. There are many, many, many such dimensions that you have to think when you're in the cloud. Now, when they deploy to Azure, just deploy your jars, you're done, and then open up your monitoring tool, Dynatrace. There you go.
So you don't have to, just wanted a quick question on that, Randy. When you're uploading your jars, you don't have to say how much memory you think you need to run this, right? Is this all like an opinionated platform where it's going to figure this all out for you? Like you literally just say, take it and run it, and that's it, and Azure takes care of all the rest, sizing and everything else?
The default is opinionated. But that's not enough for every usage, right? You can certainly start dialing up and dialing out, right? So you can say, I want 4 cores, I want 6 gigabytes of RAM. Simply ask for it, how much ever you want for one instance, right? Once you ask for one instance, and then when you are serving the loads, it's completely different. You can declaratively state when the load reaches a certain point, multiply by 2 instances, multiply by 3 instances, multiply by 500 instances, right?
Yeah.
Those declarative statements, well, you don't have to worry about what is the machine underneath it. You don't have to worry about what Kubernetes is running, what API is running. You just declared it. And as the load changes, you would see Azure doing the hard work of scaling out and scaling back in. Now, that could be a load-based meaning they can watch the CPU, watch the memory, watch the threads, watch the inbound requests, anything they can declaratively state it. They can also come up with something like schedule-driven. Like if you know November, Thanksgiving week is going to be busy, you can predefine for that week, say, hey, I want to have a constant load, and above that constant load, I want auto scale, right? So you can have all those. Now here again, it's a great opinionated platform that once you declare it, you don't have to worry. Azure will take care of the hard work of scaling every layer out and in to meet what you have declaratively asked for.
Now, technically, what runs underneath the hood? So, do you have really like run VMs, and then on every VM you have your Java runtimes, or do you actually containerize it and then run it on Kubernetes and take Kubernetes orchestration? What happens behind the scene, if you can tell us?
Azure Spring Cloud is built on Kubernetes. So you get the power of Kubernetes, but you don't have to learn, manage, or govern, or touch anything, right? So if you look at the inside of Azure Spring Cloud, every service instance has 2 Kubernetes clusters. One cluster is reserved for the runtime, where we run all the Spring Cloud runtime elements, logs, app lifecycle, security, all those runtime elements are running in one cluster. And the second cluster is reserved for your applications. So when you're deploying, inside Azure Spring Cloud, it'll take the jars, it'll take the code, and it will convert it into a OCI compliant container image and then deploy it to the app cluster. Right? So that way, it is built using Azure Kubernetes Service, but it's completely abstracted away from our users. All they have to worry about the jars or the code, upload, and you're done, and everything else is taken care of behind the scenes.
So that means if I understand this correctly, because you mentioned earlier, by default you have some opinionated deployment or the opinionated settings, but you can override them. That basically means that the settings will then influence the Kubernetes deployment configuration for your container, like your resource limits, and then the JVM, obviously, that you then run in these containers. Can you override some of the JVM parameters as well? Like, is this also possible that you override the opinion not only on memory sizing, but also on the classical JVM parameters?
Yes. Anything that you do today when you're running a jar, we want to maintain it for you, right? No changes. So if you're setting the JVM options, in the JVM options, you'll be configuring many things. All of those are available. The other thing, which is very important for developers, is hydrating information from the environment, right? So there's a way to declare the environment variables, and you can hydrate it. Now, some of them are configuration. You can just hydrate the configuration, but some are secrets, like connection parameters. So this is where you do not want to put the connection values inside an application just willy-nilly, because that just introduces data exfiltration risk. Anybody can steal information and steal the data after that. So to avoid that, we have the concept of Azure Key Vault. You can store all your secrets centrally. It can be administered by your security team. And at the app level, all you have to say is, my secrets are coming from there. and then the app knows how to hydrate them at startup time. And when it hydrates, it only hydrates in memory within the app scope. And when the app disappears, then the secrets also disappear, right? And Key Vault also gives you a complete auditing. So you also know who touched the secret. And that way, in future, if you figure out through auditing somewhere data got lost, you can trace back to who picked up the secret.
It was Andy.
Exactly. Hey, then, fascinating. You talked about the scaling, basically rule-based scaling, or you said declarative rules. Are these rules based on resource consumption? So you say if you hit a certain CPU utilization or memory utilization, or can you also scale on other, let's say, more performance-relevant metrics like response time or anything like this?
So there are many, many metrics you can use it, right? Earlier, when I called out a few, those were the ones that are popularly used by developers, right? So you can scale based on CPU, how much CPU is being consumed, how much memory is being consumed, how many threads are being spawned, how many requests that are coming in, how much response time. Or you can do a complex, right? You can combine some of these and have different set of declarative rules. I remember there's about 29 metrics that are there. You can pick whatever you want. These metrics are directly from the JVM itself. That way, you can figure out, because there is no one size fits all. Right? Different businesses have different needs.
Now, the reason why we actually got to talk in the first place is because you work with one of our colleagues, Safia, and she wrote a nice blog article and actually explaining how we bring observability into Azure, into these Spring Boot applications. Now, from a technical perspective, I think now, as you explained, that underneath the hood there's Kubernetes, and you're basically on the fly creating a container with the jar. I saw that you provide an option to specify environment variables. Like in our case for Dynatrace, you specify the API token, the endpoint. And I assume in the integration that you built with Dynatrace, when you package that container, you automatically then load our agent in and parameterize it. Is this the way it works, or is it more is it on the container level, or are you able to also install us on the Kubernetes cluster level? How does that work?
Sure, yeah. So first, I want to thank you for the great partnership, particularly from our end developers point, right?
Yeah.
Many of our developers, they are very familiar with Dynatrace. Even beyond familiarity, they have existing systems that are already instrumented. And when they come to cloud, a portion of that is coming to cloud. So they want to watch the entire system using Dynatrace, right? So from this point of view, thanks for the great partnership, because it really helps our developers. Now, for the details, now each of these container images that we are creating behind the scenes, the Dynatrace agent is installed at the OS level, and it is configured in a way all the developers have to do, our end developers have to do, is simply provide the parameters. Like there are 3 parameters that you have to provide for the Dynatrace. Once you supply those 3 parameters, either as an environment variable for the app, or through Terraform, or through CLI, or through ARM templates, it gets activated.
Cool.
And the activation happens behind the scene. Now, the agent by itself is a software. Anytime you deliver a software like that, Dynatrace as a company will also be maintaining it and evolving it and releasing, right? So from this point of view, both companies, Microsoft and Dynatrace, will work together to make sure the latest agent is always installed for developers, right? That way, they don't have to worry. All they have to do is activate, and they're done. Activate your Dynatrace, and you're done. You just open up your Dynatrace portal. You're going to see your farm of apps talking to each other, the data flow. You can see how much memory is being used. There's a lot of intelligence as well. The Safia was showing us, it was amazing. And many of our customers are pretty excited by that.
Mm-hmm. And especially, I think you brought up an interesting point, because clearly, if you just run, let's say, an app, and it's a standalone app, a standalone service, then I assume you are also out of the box providing some metrics. That the real key comes in having a solution like Dynatrace, that these apps that are deployed might just be, a part of a bigger end-to-end application. And this is where end-to-end tracing from, let's say, I don't know, your front end that then goes into Azure, then maybe goes back into on-premise, into maybe the mainframe, even who knows where it goes to. And then you get all of this end-to-end visibility. So that's great. It's also really great the way you built it, that on the fly, you're basically building these container images, ensuring that the agent in the latest version is there. Now, do you have you seen any, because we're talking with a lot of performance experts out there, are there any additional performance recommendations that you see, or considerations for performance engineers when they are testing or optimizing apps running on Azure? Is there anything in particular they have to watch out for, or do you say actually not, because you're running on the latest and greatest hardware anyway underneath the hood? Or is there anything that people need to watch out for?
One thing we have learned a lot from many of our developers, right? Particularly on some of these areas. One of the things that very key is, they have been running it on-prem. Right? On-prem, your resources are finite, and you're running within that. Right? Now you come to the cloud. There's no longer finite resources, right? It's unlimited resources. You can just turn it on however you want. So some of our customers or developers, when they ran it on-prem, they say, okay, we have been monitoring 300 stores. And we are limited by what hardware, that's all we can do. And we come to the cloud, now we are monitoring 3,000 stores, 3,500 stores. You just went from 300 to 10 times monitoring, right? So your base just expands, right? When that expands with scale out, there are many things that happen. Right? One is how is your memory used? Suddenly you get a lot of production scale data which you have never tested before. And you see this memory consumption, and then you see, hey, that app is running out of memory, this instance is running out of memory, that instance is running out of memory, which you never saw before, right? And it is touching newer edge cases, right? So when you're in that situation, you want a tool like Dynatrace, right? Where Dynatrace by itself will pick it up, it'll baselines and then shows you the anomalies, right? And those anomalies can be alerts even before out of memory happens and becomes fatal. And then you have to look at the fatal scenario and understand what happened, right? So that's one thing we saw over and over again. Now, when you go from 300 stores to 3,000 stores, there's so much data coming in, right? And managing that farm is also a pretty big challenge, right? And then we saw customers who were developers who were streaming in events. And when those events are coming in, they're keeping the CPU high, very high, right? In the on-prem world, when they had limited finite set of machines, it basically went into throttling, right? Now, when you're in the cloud and you're scaling out, it's just boom, unlimited resources come in to suck in all the events. So when you're processing that scale of events, then you want to see what is happening inside, how you can optimize for the best result. How much, if you're doing that kind of testing, the capacity planning is very important. So for that capacity planning, you probably want to look at tools like Dynatrace, where you want to see how much is being consumed. So you can come up with the combination of the declarative set of rules that helps you to go at scale in an unlimited scaling environment.
Mm-hmm.
Cool. Yeah, and I imagine with those rules, it's great that you have the multiples that you can do. For instance, if my CPU is at 70% and my response time has degraded, then I want to go up. But if my response time hasn't degraded yet, we can let it go up higher. I imagine a lot of the testing, right? If you think about from a testing point of view, anytime you go into cloud, cost always becomes a factor, right? And I think that's part of performance testing these days, or should be at least. Like when you're moving something from, let's say, VMs or whatever you're running on-prem into the cloud, as you know, you said there's those opinionated defaults, which if they're in small chunks, they might work fantastic, whereas in the CPU to memory ratio is being utilized well, and as you scale, you're using those fully. But monitoring that to make sure that's correct. You know, what if your setup is you're only using 10% of the memory on each of those, but you keep scaling because you need more CPU? Well, that's another performance issue to look at so that you can override the opinionated. This way, as you do scale, you're scaling the right size components. To me, it's always fascinating, this idea that, in performance, when you go to cloud, making sure that cost and proper scaling under real load is taken into consideration, something that people didn't have to do as much as on-prem because you didn't have these options. You had what you had on-prem, and you couldn't control it anyway. It was like, do we have enough capacity? Yes, great, we're good. With cloud, it's a whole new world, and there's been a lot of other podcasts and all that discuss that approach to testing. But it's very fascinating, and I think it's also fantastic that you have all the controls in place to control that.
I think to the point that you just mentioned, we see developers when they go into production, they're coming from the on-prem world, so they're very conservatively setting up the capacity, right? Most of the time when they go into the first production, it is over allocation of resources. And then they figure out how it is scaling out and scaling in. And they really see the actual consumption during different periods of time. And then they're able to efficiently allocate them so that they get the best utilization and the best bang for the bucks that they are spending, right?
Yeah.
Particularly in an unlimited infinite scale environment. And I see them doing that, and that's where tools like Dynatrace really helps them to look into it and understand what is actually being consumed. Right? And then how can they translate into real capacities? And then since they're able to save some money, they can have more projects running. Right?
Yeah.
And that way they can expand their business apps space.
One more question from a development perspective. Do you also provide, because you mentioned in the beginning, I think you manage the life cycle. What does this mean? Do you provide separation between pre-prod and prod? So do you allow if I'm a developer and I have a Spring Boot app, do you allow me to, using Azure DevOps, or maybe it's something else that you provide, to take this, first deploy it into a pre-prod environment, then run some tests, evaluate, and then push it forward to production? Do you also provide this as part of your offering? Or is this something that you would kind of build on top of it, and then maybe using two Azure Spring Boot environments to separate pre-prod and prod?
So I can answer that in different layers, right? So Azure by itself provides many different ways to organize it. One way we see developers organize is they use different subscriptions, right? There's one Azure subscription dedicated for prod, other Azure subscription dedicated for UAT, another one dedicated for dev and test, right? So they typically use 3 or 4 subscriptions like that. Now, within these subscriptions, the prod can have multiple instances of Azure Spring Cloud, particularly if you're thinking about global, right? You could have 2 regions installations in America, let's say South Central and East US, one in Amsterdam, another one in Singapore, another one in Hong Kong. You can have multiple instances of Azure Spring Cloud. Now, when the calls are coming in, they can come in through a front door, Azure front door, or F5. That can do the switching by regions, right? So if I'm coming in from San Francisco, I might be Seattle or San Francisco, I'll be directed to South Central in Texas. If I'm coming in from London, I'll be directed to Amsterdam. Similarly, if I'm coming in from Singapore, I'll be directed to Singapore. So that level of switching will happen at the front, and then they can be sent to different environments, right? Different regions, right? In production itself. Now, within that production instance, we give you, for each app, a way to stage the app and then swap the staged app to production. Right?
Okay.
Now, that's for that one. Now, when you are in the development, if you're a dev test environment, let's say your dev test is going in Texas, you have an instance running in Texas, and you can set up the deployment in a canary style, right? Every time I check in, it just gets deployed. Every time I check in, it gets deployed, right? So that's the canary style. So the key thing is Azure gives us all the building blocks for developers. So the developers can build what they need from a business point of view, from a team culture point of view, so that they all can be successful.
Are there any, I think you mentioned earlier, what the great thing about your offer is, I don't have to worry about whether I have one user on my system or a million users on the systems. Hopefully it's a million or even more, because you build something that all of a sudden becomes very popular. But do you have best practices on how you need to write these apps to really leverage the scalability factor that you provide? Because I'm pretty sure I can write an app that works perfectly for one user and for two, but still, even if I put all the hardware on it, it doesn't scale because I don't follow certain best practices and principles. Do you have guides for developers that are new to the platform, to that runtime, to that framework, to say, hey, and this is how you should write your app so you can truly leverage the scalability effects of it?
To start with, you can deploy any Spring Boot app, right? That's very important. The Spring Boot app could be a monolith, it could be a microservice, or somewhere in the middle, right? Anything is fine. You'll be able to deploy, and you'll be able to run at scale. All of those things are fine. If you like to, as you said, if you like to use the best power, right, that Azure and the cloud platform and everything provides you, the 12-factor principles are great. That is all you need, 12-factor principles. Principles like externalizing your config, use registration and discovery. Do not write logs to a file system, but push them all to the console, standard in and standard out. Right? Those kind of the 12-factor principles, right? Don't save any business state inside your app. Always store your business state in a database. And if you want to accelerate that, always use a cache like Redis cache, right? So if you follow those 12-factor principles, then you're in a safe place. You can get the best out of the cloud, right? This is where when you pump all the logs and we pick up all the metrics, it can show up in Dynatrace, it can show up in Azure Log Analytics, then you can really monitor the systems, right? But if you write to a file, that's the old world, right? When you do it on on-premise systems, then you are dependent on some file system. That dependency, all of those things can be taken out. Right? So simply following the 12-factor principles will get you to an amazing place in the cloud.
And I think this is also the time when we should actually maybe reference back to Brian. Remember, I think it was 2 years ago when we had a session with Josh Long, I believe. Right? He's also one of the advocates of Spring. And I think back then we also talked about 12-factor apps and the benefits of Spring Boot. And that's great.
I think it's important to state the 12-factor. It's not just for Spring, that's for anything, right? I mean, at least most cloud. Because what we see, and this is the funny thing, is that sometimes we see people wanting to get in the cloud, and while technically you can take in like lift and shift into the cloud, they'll be like, hey, I have my monolith application, I'm going to lift and shift that to Kubernetes. And it's like, yeah, you can do that, but if this is your introduction to Kubernetes and the introduction to the cloud, it's going to be a terrible, terrible experience. you really should take the time to refactor and move with that. So, that 12-factor app approach, I think, is just so critical as you go into the cloud. And, going cloud native and designing, re-architecting for the cloud is just, it might be more upfront work, right? Maybe like, hey, let's get on the cloud. But I think what we've seen from plenty of people is that cloud experience is going to be pretty horrible if you don't do it for the cloud. Yes, you can, but it's just going to be so painful. And, I don't know. I just can't stress it enough that I encourage everybody to refactor for cloud, but that's my opinion.
One thing we want to help many of these developers is, particularly if they have monolith app, if they want to go to the cloud, we like to offer them some recipes that they can quickly apply the 12-factor principles, because many of those are clerical. Some of them requires thinking, but most of them are clerical. And we are also thinking, we are working with the Spring community to see if we can have some machine automation that automatically runs through the clerical approach, right? That way they can get to utilize the best experience on the cloud.
Cool. Hey, well, first of all, thank you so much for all the information that you gave us. I was not that aware of all of the offering and what it can truly bring to developers. I think that was great. Also great to know the partnership that we have, that our two companies have, that you thought ahead and really made sure that external tool vendors like Dynatrace can, get bundled automatically into these containers that you built to do, like in our case, observability and monitoring. Is there anything we missed out? Is there anything else you wanted to make sure people understand? Or is there maybe a good way to start, way to look at?
I want to mention two things. We talked a lot about Spring Boot app. From Azure point of view, any Java ecosystem is pretty large. There's Java SE, Tomcat apps are there, Spring Boot apps are there, Java EE, there's JBoss, WebSphere, WebLogic, Wildfly. Any app type, any app server, you can deploy them all on Azure, right, across Azure.
Yeah.
And you can use any monitoring tools, including, importantly, Dynatrace, on any of these systems and monitor. You can deploy them to containers, you can deploy them to virtual machines, you can deploy them to Azure Spring Cloud as well. So that way you can monitor using any of these tools. So that's one important thing. The second one is recently, Microsoft, Dynatrace and Microsoft in collaboration announced Dynatrace software as a service on Azure. This is an amazing offer for many of our customers because it offers a turnkey solution. So they just turn it on and it's there for them, and it's operated by Dynatrace. And what important thing they're going to get is, when you monitor using Dynatrace, you could be running it on your on-prem system and monitoring it in the cloud. There's egress cost associated with it. But when you run it in Azure, particularly using this software as a service, then there's no egress cost.
Yeah, that's a very good argument. Yeah.
So turnkey and no egress cost is an amazing combination to take advantage of that.
Yeah, and you're doing a pretty good job in advocating for our partnership and for Dynatrace.
I think it's a great partnership. We love working with your teams, and we love to continue working along those tracks to make sure our developers get the best.
Yeah, cool, perfect. Hey, Brian, any final parting words from you?
Yeah, just my every time we talk to anybody from Microsoft, I always have the same thought, and I always reiterate it because for anyone who's been listening for a long time, you've heard this before. But for anyone who's new, or anybody who just hasn't thought of Microsoft or Azure, I should say, too much, it's who was it? Who said it's not your father's Microsoft? Who was that guest a while back? Brown was it?
No, it was either Brown or it was Kelsey Hightower actually.
I think
it was Donovan Brown.
Donovan, yeah. It's the fact that we're sitting here talking about Java Spring Boot. It just always astounds me, especially going back to the old school Microsoft. But also the fact that, first we had this idea of serverless functions where you just drop your function in, and Then it was, okay, you can run your Kubernetes, and now Kubernetes was offered as a system. And now we have the Spring Boot abstraction, and it's, where cloud is going is just so amazing. It's such exciting times to be living through in a technological point of view. So, hats off again to Microsoft and Azure for everything you're doing on the cutting edge with that, and for really just breaking the old mold. And, who would have thought we'd be here with that from way back? So it's pretty awesome to hear all this stuff, and thanks for being on.
Thank you for the great conversation. Yeah.
And we want to make sure that we are putting the links to the blogs that we have, right? I see you're also on Twitter, at least from the name here. So I will put that in case people want to follow up. I'm sure they can connect on LinkedIn or Twitter. And yeah, we'll make sure that everything is there in the description of the podcast.
Yes. Sounds good. Yeah.
All right. Well, thank you for listening, and thanks for all of our listeners for tuning in once again. If you have any questions or comments, you can reach us at pure_DT or send us an email at pureperformance@dynatrace.com. Once again, we'll have all the other links in the show notes. So thank you, everybody, and have a wonderful day. Bye-bye.
Happy Halloween.